Okay, here we come to section 6.6, solving quadratic equations by factoring. Up until now, we've spent chapter 6 learning about factoring, developing our factoring skills, learning various factoring methods and techniques, and now we're going to put all that to use in solving some equations with the help of factoring. And the key fact that this all depends on is something that we're calling the zero factor property. That's the fact that if you have two things multiplied together and the result is zero, the only way that can happen is if one of the two things you were multiplying was zero. So if I say, I'm thinking of two numbers, and I'm not going to tell you what they are, but I will give you this hint. When you multiply the numbers together, the answer is 0. Well, just from that, you know that one of the two numbers I was thinking of must be 0. The other one, you have no clue about. Might be 3, might be 7, might be 1700, but 0 times anything else is 0. So when you see two things multiplied together equal to 0, you can jump from that to saying, okay, either the one thing is 0 or the other thing equals 0. So here's an example of that. And the way I've got this structured is I'm going to start by showing you a few examples. Then I'm going to stop and give you the general idea, the instructions or the steps that you go through to solve an equation this way. And then we'll go back and look at some more examples. So x minus 3 times 3x plus 7 equals 0. Remember what I just said? When you have something times something else equals 0, either the something equals 0 or the something else equals 0. So here that means either the x minus 3 equals 0 or the 3x plus 7 equals 0. So now we have these two simpler little equations to solve. These are both linear equations because they only involve x, not to any power, just x itself. And to solve x minus 3 equals 0, I would add plus 3 to both sides, and I get x equals 3. To solve 3x plus 7 equals 0, first I would subtract 7 on both sides, so that 3x equals negative 7. And then to go from 3x to just x, I would have to undo this multiplication with division. I'd have to divide both sides by 3. So that gives me x equals negative 7 divided by 3, which is negative 7/3. So we ended up with two solutions, two possible numbers that x could be, 3 and negative 7/3. So the equation we started out with would be true if we put 3 in for x. Then we'd have 3 minus 3 here would be 0 times 3 times 3 is 9 plus 7 is 16. 0 times 16 does equal 0. And really it doesn't matter what this second thing is. If this first thing is 0, 0 times anything is 0. And the other solution was negative 7/3. If we put that in for x, then that makes this second factor 0, and then whatever this first thing is times 0 is going to be equal to 0. Next example, 4 times x minus 2 times x plus 11 equals 0. For this whole thing to come out equal to 0, one of the factors has to be 0. So we could say either the 4 equals 0, or the x minus 2 equals 0, or the x plus 11 equals 0. Now the 4 equal to 0, we can just forget about that. 4 is just a number. It's just the number 4. It can't be equal to 0 because it's too busy being 4. So no matter what's going on with x, 4 is never going to equal 0, which means this isn't going to do anything to give us a solution to the equation. We can pretty much ignore this as far as solving the equation is concerned. But we are going to look at these other two factors. X minus 2 could equal 0 when x is 2. Add 2 to both sides. The other possibility is that x plus 11 could equal 0 when x is negative 11. Subtract 11 from both sides. So there we got our two solutions, two things x could be, 2 or negative 11. Now here, this is not in the form of something times something else equals 0. Instead, it has x squared minus 5x plus 4 equals 0. Anytime you've got an equation like this that involves x squared, or there might be a different letter instead of x, but whatever the variable is, if it's squared, we call this a quadratic equation. And we're going to be solving this by factoring, and then that turns it into the kinds of things we were just doing. So I'm going to take x squared minus 5x plus 4 and factor that. So the two factors that it breaks up into are both going to start with x. They're going to end with numbers that multiply to give you 4. So it could be a 4 and a 1, could be a 2 and a 2, could be a positive times a positive, or it could be a negative times a negative. But those numbers have to add up to negative 5, so that when we FOIL, the outside and the inside combine to give us what we have in the middle. And so the correct factoring turns out to be x minus 4 times x minus 1 equals 0. Now, all the rest of the examples, I'm not going to stop and explain how we do the factoring. I'm going to assume that you know how to factor. And if you need a refresher on that, go back to the earlier sections of the chapter and look again at how that works. But I'm not going to spend a lot of time in how we get from something like this to something like this. I'm just going to show you what we do get when we factor. And now that this is factored, remember what happens next? We take each individual factor and set it equal to 0. So x minus 1 equals 0, or x minus 4 equals 0, or x minus 1 equals 0. And then we solve each of these dinky, simple little equations. Add 4 to both sides, we get x equals 4. On this one, add 1 plus 1 to both sides, x equals 1. And if you wanted to check, go back to the equation we started with. If I plug in 4 for x, it looks like 4 squared minus 5 times 4 plus 4, which would be 16 minus 20 plus 4, and that does equal 0. And with the other solution that we got, when we plug in 1 for x, 1 squared minus 5 times 1 plus 4 is 1 minus 5 plus 4, and that does equal 0. So there's our solutions, 4 and 1. Next example, the equation that we're trying to solve here is x squared minus 3x equals 18. Now, this is our whole approach here is based on that zero factor property, but that only works when you have factors equal to 0. Now, I don't see a 0 in this equation. Over here, where we had a 0 in those other examples, instead there's an 18. So I say to myself, gee, I wish that were a 0. I wish we had a 0 on one side of this equation. What can I do to get a 0 here? I know. I can subtract. I'm allowed to subtract the same thing from both sides, so I could subtract 18 as long as I do it over here. So when you subtract 18 on both sides, you get x squared minus 3x minus 18 equals 0. Now it's the same kind of thing we were looking at in that last example. So the next thing we want to do is factor x squared minus 3x minus 18. Remember, the factors both start with x and they end with numbers that multiply to negative 18 and that add to negative 3. So the factors are x minus 6 times x plus 3 equals 0. Now we split it up into the two separate equations. X minus 6 equals 0, or x plus 3 equals 0. And then solve each of those equations. Get x by itself on one side equal to whatever number it's equal to. So if you add plus 6 to both sides, x equals 6. Over here, subtract 3 on both sides, x equals negative 3. Those are the solutions, 6 and negative 3. So now here is the general procedure. Here is the way this method works. Step 1, get a 0 on one side of the equation if it isn't already like that. Sometimes it already will have a 0 on one side, but if it doesn't, that's the first thing you need to do is get a 0 on one side by taking what is there and subtracting it, or if it's negative, you could add the opposite, and you have to do the same thing to both sides. Then once you have a 0 on both sides, on that one side, then look at the other side with all that stuff on that side and factor that. You might want to do some rearranging or combining first, but then you'll have to factor it into something times something else. And then break the whole thing up into separate, simpler, dinky little equations by setting each factor individually equal to 0. And then solve the resulting simple equations. So now that we know what we're doing, here's another example. 2x squared plus 7x minus 15 equals 0. First thing to check, do we have a 0 on one side of the equation? Why, yes. Yes, we do. So we don't have to worry about that. Step 2, factor the side that isn't 0, the 2x squared plus 7x minus 15. So we have to break that up into two factors that when you multiply them together, they give you x squared plus 7x minus 15. Now here I'm just showing you what those factors are, but you might have to stop and work this out. I don't expect you to be able to necessarily immediately see this. You might have to work out the details, but once you find the right thing, let's check it. 2x squared plus 10x minus 3x, so together that's plus 7x, minus 15. When you use the FOIL method on this, you do get back to 2x squared plus 7x minus 15. So those are the correct two factors. Step 3 is to take each one of the factors and give it its own separate little equation where that factor by itself is equal to 0. So 2x minus 3 equals 0, or the other equation says x plus 5 equals 0. And now we just have two simple little equations to solve. On this one, I would add 3 to both sides, and then go from 2x to just x by dividing by 2 on both sides. 2x divided by 2 would be x. 3 divided by 2 would be 3 over 2, 3 halves. Meanwhile, over here, subtract 5 on both sides, you get x equals negative 5. And there's your two solutions. Okay, I've told you everything you need to know, but I want to work through some more examples so you really get the hang of this. So I'm going to end this video here, and then in the next video, I'm just going to work through a bunch more examples so we can really be sure we know how this works.